My project is a sequence of 2 lessons with the goal of providing high school students with an introduction to polynomials in one variable that emphasizes polynomials as a system or a ring similar to the integers rather than functions. The first lesson focuses on definitions that emphasize the structural form of polynomials. The first lesson begins with a warm-up where students are asked to identify the differences between 2 sets of expressions, and the idea here is to get students to start thinking about the differences between polynomials and other expressions without knowing that they're doing so. Hi everyone! We're going to begin today's class by going over some definitions, so please take out a piece of paper and a pencil and copy down everything that I write down on the board. So the first definition we're going to discuss is the definition of a term. So a term is a number or variable by itself, or a term is a product of numbers and variables. So this definition is saying that a term could be something like 2, pi, or 3, which are just numbers by themselves, or a term could be something like x, y, or z, which are just variables by themselves. However, a term can also be something like 3x, which is the product of a number, 3, and a variable x. We could also have something like 5xy, which is the product of a number and 2 different variables. One final example would be something like 6x squared, which we can think of as 6 times x, and this is a product of numbers and variables. Some examples of things that are not terms are things like 2 plus x. This is not a number or variable by itself because we have a number and we have a variable. And this is also not a product of numbers and variables because we have an addition sign separating them. Something else that is not a term would be xy squared plus y minus 1. Again, this is not a number or variable by itself, and it's not a product of numbers and variables because we have an addition and subtraction sign separating them. So these 2 things are not terms. The next definition we're going to go over is the definition of a polynomial. So a polynomial is a group of 1 or more terms separated by addition and or subtraction. So an example of a polynomial would be something like 3x squared plus 5 minus 1. So here we have a group of 3 terms, 3x squared, 5, this should be 5x, and 1. And they're separated by addition and subtraction signs. Another example of a polynomial would be y minus 5. So here we have a group of 2 terms, y and 5, and they're separated by subtraction. Another example of a polynomial would be xy plus y squared. Again, we have 2 terms, and they're separated by addition. One last example would be just the number 3. So this definition says that we need a group of 1 or more terms. So 1 term by itself is a polynomial, and 3 is a number by itself, so by the definition of a term, this is a term, and therefore it's a polynomial. So as we can see here, a polynomial can have more than 1 variable, However, for this lesson, we're only going to be focusing on polynomials that have one variable. So polynomials like this one, and then also technically this is a polynomial in one variable because we can think of this as 3 times x to the power of 0, and anything raised to the power of 0 is 1, so 3 times 1 is 3. So we're going to look at polynomials of these types. So there are some rules about polynomials. There are some things that they can and cannot have. So a polynomial can have constants and variables. A polynomial can also have exponents, but it can only have exponents that are positive whole numbers. A polynomial can also have addition, subtraction, and multiplication. And then lastly, a polynomial can have division by a number. So that means we could have something like x divided by 5, which is the same thing as 1/5 times x. So this is technically, can also be thought of as multiplication. There are also some things that a polynomial cannot have. So a polynomial cannot have division by a variable. So this would be something like 5 divided by x. A polynomial also has certain types of exponents that it can't have. So the first type is a negative exponent. So you can't have something like x raised to the -2. A polynomial also cannot have exponents that are not whole numbers. So you can't have something like y to the 2/3, for example. And then lastly, a polynomial cannot have an exponent that has a variable. So you can't have something like 5 to the power of x, for example. And then lastly, a polynomial cannot have any variable under a root. So we can't have anything like the square root of x or the cube root of y. These are not allowed. Next, the students will do a whiteboard activity that ensures that they understand the definition of a polynomial. I like these activities because they encourage all students to participate, especially the more quiet ones who aren't comfortable raising their hands. It also allows me to assess immediately for understanding. We're going to discuss a few more definitions. So the first definition we're going to talk about is the degree of a polynomial. So the degree of a polynomial that has one variable is the largest exponent of that variable. So for example, the degree of the polynomial x squared plus 3x minus 4, the degree of this polynomial is 2, because this is the largest exponent of x in this polynomial. Polynomials are given certain names based on their degree. So a linear polynomial is a polynomial with degree 1. So that means the highest exponent of its variable is 1. So an example of this would be something like y plus 7. Here, y is technically raised to the power of 1, and that's the highest exponent of y in this polynomial. There's also quadratic polynomials. So these have degree 2, and an example would be x squared plus 7. And then lastly, we have cubic polynomials. Which have degree 3. And that would be something like z to the power of 3 plus z would be an example of that. Polynomials with higher degrees also have names. However, these are the only ones we're going to worry about memorizing for now. Next, the students will do another whiteboard activity that ensures that they're able to identify the degree of a polynomial and classify a polynomial based on its degree, and also that they're able to identify the terms in a polynomial. The first lesson ends with a graded check for understanding. This is really more for my use to see where the students are having difficulty, and the questions are meant to ask the students to think a little bit deeper and really test whether they actually understand the definitions that we went over in this lesson. The second lesson explores adding and subtracting polynomials and alludes to the fact that polynomials are closed under addition and subtraction. The lesson will begin with a warm-up where the teacher plays a short clip of this comedy sketch where a man is making a fast food order, but basically he's just saying the same thing over and over again. So he asks for 3 burgers, then 2 fries, then has to take away 2 burgers, and so on. The idea is to get kids thinking about how we can say the same thing in fewer words, and we can apply that same idea to simplifying polynomials. Hi everyone! So we're going to begin today's class with a couple of definitions. So please take out a piece of paper and a pencil and make sure that you're copying down everything that I write down on the board. So the first definition we are going to talk about is like terms. So like terms are terms that contain the same variable raised to the same power. So some examples of like terms would be things like 2x and 3x. These are like terms because they contain the same variable, x, raised to the same power, which is technically 1. Another example would be 3x squared and 5x squared. So again, these have the same variable, which is x, raised to the same power, which is 2. And then one last example would be 2 and 4. So 2 can be thought of as 2 times x to the power of 0. 4 can be thought of as x times the power of 0. 4 times x to the power of 0, excuse me. So these two things have the same variable raised to the same power, which is 0. Here is a polynomial that has like terms. So what I'm going to do is box all the terms that have x squared. I'm going to underline all the terms that have x. I'm going to make sure to include the sign in front of the term. And then I'm going to draw a triangle around all the the constants. So here I have 1x squared, right? Because there's an invisible 1 in front of the x squared. So we can think about this as having one hamburger, like in the video. Here we have 3x squared. So we have 3 hamburgers, but it would make sense to just lump all the hamburgers together. Why do we need to say that we have 1 hamburger and then say that we have 3 hamburgers? We might as well just lump these all together and say that we have 4 hamburgers in total, so 4x squared. Over here we have 2 x's, or maybe 2 Cokes, and then we have 1 negative x. So again, we can just lump them together. If we have 2 positive x's and 1 negative x, we can just think about it as having 1 x. And then over here we have 5 1s, so maybe 5 fries, and then we have 3 minus 1s, so minus 3 fries. So we can just lump all of these together. If we have 5 fries and then we take away 3 fries, we have 2 fries. So just 2. This is the same polynomial as this polynomial. It just says it in fewer words, or in this case, fewer terms. What we just did here, this process of combining the like terms, or lumping the like terms together, is called combining like terms. And a polynomial, such as this one, that has no like terms left, so we've combined all the like terms, we say that it's in simplest form. And we always want our polynomials to be in simplest form, just because it keeps things concise and you're saying the same thing but in fewer words. Next, the students will do an activity involving polynomial cards, which are attached to the end of the lesson. So basically, they're going to be sorting the cards according to like terms, and once they've done that, they're going to combine the like terms in each pile. All right, the last thing we're going to talk about today is adding and subtracting polynomials. So we're going to talk about adding polynomials with an example. So let's say we have 3x plus, x squared plus 3x minus 4. So that's one polynomial. And we want to add to it 2x squared minus 4x plus 7. So what we can do is put a 1 in front of these polynomials, because you can think about there being an invisible 1 in front of each polynomial. And then when we distribute the 1 using the distributive property, we can just get rid of the parentheses. So when you're adding 2 polynomials, you can just ignore the parentheses right away, because we're just distributing a 1, which keeps the polynomials the same. So what we have to do here is notice that there are several like terms. So I have x squared and 2x squared. I have 3x and minus 4x. And I have minus 4 and plus 7. So what I want to do is combine like terms. So I'm going to combine my x squared and my 2x squared to get 3x squared. I'm going to combine my 3x and my minus 4x to get minus x. And then I'm going to combine my minus 4 and plus 7 to get 3. So this polynomial is in simplest form. And this would be the solution to this problem. You always have to make sure that it's in simplest form, and that means that all the like terms have been combined. So this lesson ends with a graded check for understanding that asks students to subtract 2 polynomials, add 2 polynomials, and write their results in simplest form. It also gets them thinking about the idea that polynomials are closed under addition and subtraction.